Hello students, this is Unit 4.3, Using Studies Wisely. The scope of inference refers to the type of inferences or conclusions that can be drawn from a study. Two types of inferences, or the types of inferences we can make, inferences about the population and inferences about cause and effect, are determined by two factors in the design of the study. Were individuals randomly assigned to groups? That means, did you take your group of subjects and did you randomly say, okay, you're going to get the treatment, you're going to get the placebo, you're going to get placebo, you're going to get treatment according to some chance device? Were your individuals randomly assigned to groups? That links with the idea of cause and effect. Okay, were your individuals randomly assigned to groups? Yes. If they were, then you can make inference about cause and effect. So you get these two yeses here. If you didn't randomly assign your individuals to groups, and if you just let them go to their weightlifting or to their typical exercise regimen, to some new exercise regimen, then you just let them go. So maybe your big beefy men are going to go to weightlifting, and your chancier littler guys that are like, well, weightlifting hasn't worked, are going to go try exercise. But then who's going to be able to do more push-ups at the end? Those big beefy guys have such an advantage from the beginning. So can you make an assumption about cause and effect? No. You get these two no's here about cause and effect. Okay. Were individuals randomly selected from a population? If you didn't randomly select your individuals and you just let them come to you, then you can't make inference about the population. Okay, so yes, yes, and no, no across the top here. If you didn't take them from the population that you're trying to generalize about, then you can't make generalizations back to that population. Okay? If you did take them and you randomly selected them from the population, then you can make inferences about that population. Remember that the population doesn't have to mean the whole world or the whole US or every teen ever alive. Your population can be the student body at RB. The question is asking, did you randomly select from the student body? Or did you just let students come to you? Okay? If you just throw a poll out on Instagram about if we should have Friday late starts because you want to sleep in on Fridays, then you're just polling your Instagram friends. And they're going to probably feel a lot like you do because you're friends with them and they think like-minded. If you really want to see if how RB feels about having late starts moved to Fridays, you need to randomly select people from the whole population of RB. You need to get your freshmen, sophomore, junior, seniors, those who are sick often, those who are highly motivated, those who are unmotivated, those who are prone to be expelled, and those who have perfect attendance. Those who are athletic, those who are not, okay? Because a lot of these different things mean that people feel differently about if they should have Friday late starts, okay? So you want to get the whole population and all their opinions according to all their different characteristics. Okay, an alternate example, silence is golden. Many students insist that they study better when listening to music. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address the question at your school. In each case, the response variable will be the student's GPA at the end of the semester. 1. Get all students in your AP Statistics class to participate in a study. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to this question. Okay, is there inference about a population that you can make? No, because you only drew from the AP Statistics class, so you can't make this generalization about all students in America or all students at RB or all high school students. Okay, can you make inference about cause and effect? No. You simply asked them if you listened to music, and then you divided them up into 2 groups and you looked at their GPAs. Okay? So what you didn't do is you didn't take a mixture of GPAs, high and low, and take all your students and randomly assign them to the different groups and hopefully get that mixture of GPAs, high and low, in each of the groups. And then go ahead and apply music to some, say no music to the other group, and then see what happens at the end to their GPA. Okay, moving on. Select a random sample. That's a different start. Select a random sample of students from your school to participate in a study. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to this question. Are you applying music? No. But did you at least have a random sample of students? Yes. So can you make generalization back to the population? Yes. Because of this random sample process, you are pulling from the population that you're trying to generalize about. So you can generalize about the population. You didn't just get a niche group of people, okay? And cause and effect, you did not yet use random assignment. Okay, get the subjects in your AP Statistics class to participate in a study. So far, are we pulling from the whole school? No. So you cannot make inference, so you cannot make conclusions back to all students in the school. Because what about band students? If they constantly have music on all day long, all the time, music playing in their head, even when they don't even have headphones in, right? They're just living music. They might study a little better to music than somebody who's not used to it at all and pretty much hates music. Okay, when you start playing music for those people, they're gonna be like, whoa. Okay, so we need all people, right? Okay, randomly assign half of the students to listen to music while studying and for the entire semester, and have the remaining half of the students abstain from listening to music while studying. Cause and effect? Yes, we can make conclusions about cause and effect, because we did the random assignment process of listen to music and no listening to music, okay? So therefore, any difference that happens, we can say that we probably can say that it was due to the music itself, okay? Because we had smart and low achievers, and we had music people and non-music people, okay? And we had people with babies and people without babies in their houses, because maybe that makes a difference because they're used to tuning it out. Select a random sample of students from your school to participate in the study. Wow, that sounds like we can make generalizations back to the population, our school. Randomly assign. Oh, we can make conclusions about cause and effect. Randomly assign half the students to listen to music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. Okay. For each design, suppose that the mean GPA for students who listen to music while studying was significantly lower than the mean GPA for students who didn't listen to music while studying. What can we conclude for each design? Okay, we can conclude that those things right there. That we can make generalizations about the population or generalizations about cause and effect. Okay, very good.